When people discuss humanity colonizing other worlds, planets such as Mars, Venus, or even the moon are often brought up. But which of these is the easiest to colonize? Well, consider this from today's perspective. No future technology or terraforming involved. Could we do this today with our current technology? I'll compare the three choices, and I'll explain why exactly only one makes sense. Let's kick things off with the moon. One strong upside is distance. It is obviously much closer than the other two, and therefore costing less fuel and time to travel to, even with accounting for the planets orbiting in space and being in different places at different times. The second upside here is low gravity. The moon's gravity is only a sixth of Earth's. This is also a downside, as we'll discuss in the negatives portion. Low gravity and atmospheric pressure make it easier for rockets to take off, build taller buildings, and lift heavier equipment. The third upside here is untapped resources. Aside from some astronauts who collected some samples, no one has mined or harvested resources from the moon. That should be worth billions of dollars as an economic incentive. The fourth upside that kind of tags along with untapped resources here is water, in the form of ice in the craters. Anywhere from 100 million to 500 million tons of it. Unless you want to keep transporting water back and forth from Earth, this is important for keeping costs down. So those are the four advantages of colonizing the moon. Starting with the negatives, the low gravity is also a negative. Long-term exposure to low gravity can cause muscle and bone degeneration. Although this can be somewhat mitigated by exercise, it'll still cause negative effects. Astronauts on the ISS must do this to maintain their health. So we'd have to have people living on the moon, and after a couple hours or after a certain amount of time, they rotate out, going back to the spaceship that's in orbit, and then a new people come down so that they're not exposed to the effects for too long. A spacecraft must generate a certain thrust respectively to hover or move at a steady speed against the reduced pull of the gravity. Artificial gravity is often generated in space habitats using centripetal force, acceleration or rotation, to simulate gravity levels ranging from partial gravity to 1g, compensating for physiological deconditioning caused by microgravity or hypergravity environments. Constant rotation would cause nausea, but at some point people would learn to get used to it and not throw up after every meal. So we do have some options. Like we can have the habitat that the people are living in rotate just fast enough to counteract the low gravity, and obviously have redundant controls and systems in place just in case the rotation stops working. The second major downside here is the lack of atmosphere, and along with that comes no oxygen and colder temperatures, since the atmosphere keeps the heat within the planet, and people would need special suits to survive. The only other option we have here is to make a pressurized chamber with multiple fail-safes built in, of course. The third and final downside for the moon is no magnetosphere, which, for those of you who don't know, is this magnetic field around the Earth that protects us from solar and cosmic radiation. Protects humans, plants, and animals from being irradiated. So without being underground, which would block some of the radiation at least, or utilizing some kind of shielding, eventually everything dies. We do at least have radiation resistant materials on Earth that we can take along with us and surround ourselves or the habitat with. All in all, that gives us 4 upsides for the moon and 3 downsides, so a fair score. Now on to our next planet, which is Mars. In a lot of ways, Mars and the moon have the same positives and negatives, just to a lesser extent. I'm not going to re-explain the same points again, so a lot of what I said will still apply. For positives, we have access to the resources on the ground, and that includes water in the form of ice near the poles. And I discovered if all of it was melted, it'd be enough to cover the entire surface. So for sure, it has the most water of all of the choices we have here. So that's 2 positives in one. It has a low gravity, 38%, or just a little over a third of Earth's, which is more than the moon, but still not high enough to avoid the muscle and bone degeneration that we explained earlier. It would just happen at a slower rate. So again, that's a positive and a negative. And lastly, for the positives, we have closer access to the outer solar system for missions in deep space. And in the future, industries such as asteroid mining would benefit from Mars out of the other 2 choices here. So a minor positive for today's era, but eventually be a major positive. So that's 4 in total. Now there are 4 major negatives for considering Mars for colonization. The first being distance. It is by far the furthest of all of our choices, wasting more time and fuel to go back and forth from Earth to Mars. Unless you want to wait for specific times of the year when Mars is closer to Earth, but even then you're still waiting, so point still stands there. The lower gravity, as mentioned earlier, it's also a negative. Number 3 is thin atmosphere. It does have a thicker one than the moon's, but not enough for us to survive without suits, especially as the lack of atmosphere would make the temperature too cold. And lastly, similar to the moon, the Mars does not have a magnetosphere and all the negatives that comes with. So people would have to live either underground or in special radiation-proof bunkers. And I did some research. Living underground for long periods of time would lead to vitamin D deficiency, weakened bones, sleep cycle disruptions, and severe psychological stress. So not exactly ideal. So 4 positives and 4 negatives, so even split there. Last but not least, we have Venus. Now normally when people think of Venus, they imagine an inhospitable hellscape in which nothing can survive. And that is true. However, what if I said we don't have to live on the surface at all? At a certain elevation in the atmosphere, approximately 31 miles up from the surface, there is ideal living conditions for humans, in terms of both temperature, oxygen level, and pressure. Think Cloud City from Star Wars. Using blimps and elevated platforms with balloons, we can stay aloft. The air content is such that if the balloon is pierced, it can't deflate. The outside air would fill it back in before it could plummet us to our death. Of course, we want redundant systems, balloons, just in case it's damaged. Let's talk about the positives and negatives. Leading off with the positives, Venus does not have an intrinsic magnetic field that's generated by an internal dynamo. That means the movement of the core is what makes the magnetic field for Earth, but Venus doesn't work like that. It actually possesses a weak induced magnetosphere in which its ionosphere interacts with the solar wind from the sun. And that's what makes like a weak magnetic field around it. So there's one there, and it is stronger than the other 2 choices, but in addition to that, its atmosphere is so thick that it pretty much blocks all radiation from space, so there's not much of a concern. We can also add radiation shielding to the floating habitat. It has the most radiation protection by far, despite being much closer to the sun on average. The second upside for choosing Venus is that its surface gravity is much closer to Earth's than the other 2 choices. It's 8.87 meters per second squared, and that's approximately 90% of Earth's gravity. That's at 9.81 meters per second squared. And that's so close that we don't have to worry about the muscle and bone degeneration we discussed earlier. It's worth considering the gravity will be slightly less 31 miles up, because you're further from the core, but still, that's a good upside. You don't have to do anything special or make anything orbit, make anybody throw up their lunch or anything like that. The third positive is that its temperature is roughly 75 degrees and the air pressure won't be a problem. Like I said, it's Earth-like. The fourth positive is power generation. Via proximity to the sun, it obviously gets a lot more sun rays than Earth, and this can be harnessed with solar panels and sails. While the planet does have a lot of cloud cover, these can be placed in low orbit or in the upper atmosphere for coverage. Using spacecrafts in Venus's orbit, we can utilize solar rays to generate significantly more power than on Earth. For instance, a craft called Venus Express Arrays produced 1100 watts around Venus as compared to 800 watts near Earth. We can even place these solar arrays on our upper atmosphere platforms where temperatures are manageable and harness the power and directly power the habitat that way. Finally, we have our positive/negative, and that's distance. Now, Venus is closer to Earth than Mars is, but further than the moon is, so this lies somewhere in the middle, and I'll kind of just split it here and say it's a kind of a positive and a negative. And now onto the obvious negatives. The surface is inaccessible. Basically hell, 867 degrees Fahrenheit or 464 degrees Celsius. A crushing pressure that destroys spaceships after just a couple of hours. We can't access the surface or collect any resources. Although we can grow food on the floating platforms, we just have to either transport the soil from Earth or make compost. Second negative, there is no liquid water at all, especially not on the surface. Venus contains roughly 100,000 times less water than Earth. There is water in the form of vapor in the atmosphere that can be collected, but even if you took all the water on Venus and spread it evenly across the planet, you'd form a layer that's only about 1.2 inches deep. Compared to Earth, which would produce a global layer of around 2 miles. This is not to mention the fact that Venus is actively losing water as we speak. This means water would have to get constantly shipped from Earth unless we recycle the water. Even if we do, that would quickly rack up the cost, and that's a major disadvantage. It's the worst candidate for liquid water by far. Another disadvantage is the presence of sulfuric acid. This is the primary component of the thick cloud deck on Venus, existing as water droplets with concentrations ranging from 70 to 99% by weight, depending on the altitude. This acid forms in the upper atmosphere when sulfur dioxide and water vapor react with atomic oxygen produced by solar UV radiation. This is what creates the acid rain. It would smell like sulfur all the time, so again, just like hell, raining acid on that habitat. Now we do have industrial methods to remove sulfuric acid, which includes wet scrubbing with alkaline sorbents like limestone, dry and semi-dry scrubbing using hydrated lime and wet electrostatic precipitators. So at first, the citizens would have to live in the enclosed habitats with acid-resistant clothing and materials on hand until we can reduce the amount of sulfuric acid in the atmosphere. We could always set up and automate the industrial removal of the sulfur dioxide from the atmosphere before people even arrive. So there are workarounds to this problem, but it is quite a large one. There's one small negative, and not really all that impactful, but Venus's day lasts 243 Earth days, which is longer than its year at 225 Earth days. And even its solar days from sunrise to sunset is 116 Earth days. So there would always be constant sunlight, messing with sleep patterns and possibly mental health. We could just use shades in the habitats and simulate a 24 to 30 hour day. So not a major problem, just one worth mentioning. So that totals 5 positives and 4 negatives. Like I said, we split the distance one. So now that we've wrapped up the positives and negatives for each world, which one of these is the best candidate for colonization? Well, right off the bat, we can eliminate Mars. Even though it's often thought of as the best planet for colonization right now, just has too many negatives to overcome. The thin atmosphere leading to cold temperatures, low pressure, means you must be in a suit all the time, or at least in some kind of pressurized chamber. Without a magnetosphere, there's dangerous radiation that comes from space, so you'll need to be underground or in a radiation-proof bunker. Lastly, the low gravity, which I'm not going to touch on again. It does have more water as a major advantage, but not all of it's drinkable anyway, and the moon has a good amount of water, so from my perspective, if you want to colonize Mars, you might as well choose the moon. It has the same negatives, but to a slightly greater extent, but it also has the convenience of being closer to Earth for resources and tourism, along with less gravity. That's better for launching rockets and having some kind of space base or moon farm, at least for now. That leaves us with the moon versus Venus. Venus would ultimately be a lot more expensive due to distance and the water/soil transportation cost. With all these factors in consideration, I think the moon is the best option with today's technology, considering logistics and resources. I think Venus is a very close second, and I think I could have leaned either way. It does have gravity close to Earth. There's Earth-like conditions. There's no need to generate an atmosphere. It is a bit further than the moon is, obviously, but at the same time, there's a reason why it's called Earth's sister. If people would get out of the mentality or thought that Venus is literally hell, even though it is, but it is still like a workaround to several of its issues. So today we conclude that the moon is the best for today's technology, and the only thing holding Venus back is really just the cost of going back and forth from Venus. But after the initial setup, I think Venus could have easily been first, but I'll go with the moon for now. You should just set up the moon, maybe a moon farm or a moon mine, have some kind of habitat that's rotating, and have people live there going back and forth to the spaceship and just going back and forth from Earth and just establishing that as quickly as possible. Maybe you can launch rockets from there to the other planets. So from the moon to Venus or possibly to the outer solar system. So you know what? That kind of works for us. Mars is a distant third, and that's not the world I would consider colonizing. At least not for humanity. Maybe for frost giants. For those of you who are wondering, yes, humanity will be living on multiple worlds in the far future. In Aevium, the comic series I'm in the process of making, Earth, the moon, and Venus, and an undisclosed final world that is not Mars are all the worlds that humans are living on. To find out, please subscribe to keep up with the story when it releases, and for more sci-fi videos on the channel. Thanks for watching, and I'll catch you guys in the next video.